Anatomy of a method. Method declarations. Now let's examine methods in more detail. Method declaration specifies the code that will be executed when the method is invoked. Invoked is just another way of saying called. When a method is invoked, the flow of control jumps to the method and executes its code. When complete, the flow returns to the place where the method was called and continues. The invocation may or may not return a value depending on how the method is defined. Method control flow. If the called method is in the same class, only the method name is needed. The called method is often part of another class or object. So if it is part of another class or object, then you're going to need the object reference variable in order to call the method. Method header. A method declaration begins with a method header. You have the return type, the identifier, which is the method name, a parameter list. This is the data that you're going to pass into the method. The parameter list specifies the type and name of each parameter. The name of a parameter in a method declaration is called a formal parameter. Method body. The method header is followed by the method body. So inside the curly braces is the method body. The return expression must be consistent with the return type. If you specify the return type as a char in the method header, then you need to return a char. Sum and result are local data. So these are two variables that exist in the method. So they're local data. They are created each time the method is called and are destroyed when it finishes executing. The return statement. The return type of a method indicates the type of value that the method sends back to the calling location. A method that does not return the value has a void return type. A return statement specifies the value that will be returned. Its expression must conform to the return type. Parameters. When a method is called, the actual parameters in the invocation are copied into the formal parameters in the method header. So here is the line where the method is actually invoked. You can see they're passing in a 25 and they're passing in a variable called count, and then they're passing in string. Those values are copied into the formal parameters. So here's the parameter list of the method, and those values will be used within the method body. Local data. As we've seen, local variables can be declared inside a method. The formal parameters of a method create automatic local variables when the method is invoked. When the method finishes, all local variables are destroyed, including the formal parameters. Keep in mind that instance variables declared at the class level exist as long as the object exists. So whenever we instantiate an instance of a class, that object in memory is going to retain its instance data as long as you have a valid reference to that object in memory. Once you lose that reference to that object in memory, the garbage collector is going to come through and release that object from memory so that memory spot can be used for something else. Bank account example. Let's look at another example that demonstrates the implementation details of classes and methods. We will represent a bank account by a class name account. Its state can include the account number, the current balance, and the name of the owner. And its account behaviors or services include deposits, withdrawals, and adding interest. Driver programs. A driver program drives the use of other more interesting parts of a program. Driver programs are often used to test other parts of the software. The transaction class contains a main method that drives the use of the account class, exercising its services. So here's the transactions.java. This is a driver class that's creating account objects. Now let's look at the account object before we look at the driver class. I always think it's easier to look at the blueprint class first before we actually look at the driver. So here's a blueprint class for the account. They have instance data for account number, for balance, and for name. They also have a constant for rate, which is the interest rate. They have a constructor that takes in the name of the account owner, the account number, and the initial deposit. They take in this data through their parameter list, and they use that data to set their instance data through the constructor. Another method they have is deposit. So they're going to take in an amount and add it to the current balance of the account. Another method they have is withdrawal. So they're asking for the amount you want to withdraw and a fee. So this would be like if you withdraw from an ATM, there might be like a $2 charge. And they set the balance equal to itself minus the amount minus the fee, and they return the balance. They have a method called add interest. So what this is going to do is just multiply the interest rate to the balance and set that value back to the balance. Then they have a getter for balance. You're simply just going to return the balance. And then they have a toString method, which is essentially going to use the number format to get the currency instance and output the account number, the name on the account, and the balance of the account. So let's look at the driver. So here's the driver, which is transactions. They instantiate 3 account objects, and here are the names, the account numbers, and initial balances. Then they deposit money in account 1 and then deposit money in account 2, but they use a variable to retain the deposit deposit. So this deposit method returns the current balance. They output that balance, and then they do a withdrawal with a fee. Now they're concatenating this method to this string. This method does return the current balance after the withdrawal is complete. They add interest to all the accounts, and they print out the account object. Now whenever you print the account object, it's going to invoke the toString method. And here's what the output is going to look like. And now they're showing you a diagram of what an account object looks like. So an account object reference variable is going to hold instance data for account number, balance, and name. And the name variable is an object reference variable that's going to hold the name of the customer. There are some improvements that can be made to the account class. Formal getters and setters could have been defined for all data. The design of some methods can also be more robust. The design of some methods could have been more robust, such as verifying the amount parameter to the withdrawal method is positive. So if they're saying if you're going to withdraw money from your account, we should check the amount to verify that you actually have enough to cover that withdrawal. Constructors Revisited. Note that a constructor has no return type specified in the method header, not even void. A common error is to put a return type on a constructor, which makes it a regular method that happens to have the same name as the class. The programmer does not have to define a constructor for a class. Each class has a default constructor that accepts no parameters. Quick check. How do we express which account object's balance is updated when a deposit is made? You invoke the method through the object reference variable of the account you want to update. And their answer is each account is referenced by the object reference variable. So here you have the declaration and instantiation of account. And when the method is called, you call it through the particular object. So if you want to deposit on the object by account, then you need to use that object reference variable to invoke that method.